Hydrogen spectrum. When hydrogen gas, filled in a discharge tube at low pressure, is subjected to high voltage, it emits characteristic radiations. These radiations appear magenta in color. When they are analyzed by means of a spectrograph, several isolated series of bright lines are observed in the spectrum. As the spectrum consists of a series of lines, it is called a line spectrum. As in the case of hydrogen, any element given spectrum is characteristic of the element. Hence, the line spectra of this type of emitted light is also termed as the atomic spectrum. The hydrogen spectrum appears complex at the first sight. But the regularity and position of the lines in different series has been proved. They are known as Lyman, Balmer, Paschen, Brackett, and Pfund series. Series term M. Line term N. Name of series. Spectral region. M is equal to 1. N is equal to 2, 3, 4, and so on. Name of the series is Lyman, and the spectral region is ultraviolet. Series term M is equal to 2. Line term N is equal to 3, 4, 5, and so on. Name of the series is Balmer. The spectral region is visible. The series term M is equal to 3. The line term N is equal to 4, 5, 6, and so on. The name of the series is Paschen, and the spectral region is infrared. The series term M is equal to 4. The line term N is equal to 5, 6, 7, and so on. The name of the series is Brackett, and the spectral region is infrared. Series term M is equal to 5. The line term N is equal to 6, 7, and so on. The name of the series is Pfund, and the spectral region is infrared. Lyman series of hydrogen spectrum. The ultraviolet region of hydrogen spectrum contains about 6 lines. The frequency of radiation of this region, their wavelengths, and the energy of corresponding photons are given in the table. The wavelength lambda in angstrom, the frequency per second, energy in kilocalories per mole, the wavelength in angstrom 1216, the frequency per second is 2.47 into 10 raised to 15. The energy is 235.2 kilocalories per mole. The wavelength, 1026 angstrom. The frequency per second, 2.92 into 10 raised to 15. The energy 278.8 kilocalories per mole. The wavelength 973 angstrom. The frequency per second is 3.08 into 10 raised to 15. The energy 294 kilocalories per mole. The wavelength 952 angstrom. The frequency 3.15 into 10 raised to 15. The energy 301.1 kilocalories per mole. The wavelength 938 angstrom. The frequency per second is 3.20 into 10 raised to 15. The energy is 304.9 kilocalories per mole. The wavelength is 934 angstrom. The frequency per second is 3.22 into 10 raised to 15. The energy is 307.2 kilocalories per mole.